Identify any discontinuities. Discontinuities mean what makes the denominator equal to 0. So what makes this piece equal to 0? 0. Very good. 0 for those that said 0. Here's why. That's your discontinuity. Remember, all you do is you take your denominator and you set it equal to 0. Well, that wasn't even a hard problem because you didn't have to solve anything.
Right. So there's nothing to add or subtract.
Right, yes.
Okay, so if it was like 2 or 3, would it be y equals 3 or 2?
2 or 3. So there's many ways that you can do that. So 2 here?
Yeah.
It would still be 0.
How does the number
because 2x equals 0. When you solve that, what do you get? 0. Remember,
There's an x on the bottom, so
because the x is on the bottom, you're just setting it equal to 0. Now, for example, don't write this down. If I had minus 3 here, it would be 3. It's always the opposite. Okay, it's what makes the denominator equal to 0. Now, moving on to that part. For discontinuities that are vertical asymptotes, write the equation. Okay, so this is more practice of what we're doing. So this is just like everything in one. Remember I told you that what we were learning on Monday and Tuesday and Wednesday is going to end up being one full problem? This is the one full problem that I'm talking about, where we took it and we broke it apart. So, does anything cancel right here?
no.
So is it a whole or a vertical asymptote?
Vertical.
Vertical asymptote. So I'm going to put a little arrow here, and I'll explain that. Oh, write the equation. So if it wants the equation, you're just going to put x equals 0. Now, explain that one more time. Whenever you're finding the discontinuities, you're just listing them out. What makes the bottom 0? Then you try to identify, is it a whole or an asymptote? I'll show you an example of what would be a whole right now in this problem. If I put an x right here, like that would be a whole. Because there's an x on top and bottom. That would be a whole. But because we can't cancel, it's going to be a vertical asymptote. And what's nice is that your graphing calculator, you're going to see that there is one once we put it in there. Okay? So, for discontinuities that are whole in the graph, name the ordered pair. Do I see anything that cancels?
No.
So it's none. So if nothing cancels, you just put none. Okay, I put that there so that you have a space for every spot. Then it says, for the discontinuities that have horizontal asymptote, write the equation. So horizontal.
There's nothing to there is no reason to really divide, since there's only one x and that's at the bottom.
It is. And what is it then?
There is no horizontal.
There is. What is it?
0.
It's 0. Okay, let me explain that. If you didn't know that, please take 1 minute and flip back to yesterday's chart. The degree on the top is what?
It's a 4. I mean, there's none.
There is none. Good, there's none. So sometimes I like to write my degree out because it helps me. What's the degree on the bottom?
1.
Which one's higher?
The bottom.
The bottom. Remember that chart told you that if it's higher on the bottom,
It's horizontal.
it's 0. That horizontal asymptote is 0. Okay? So sometimes I see a lot of people, I did this last year too. Oh, that erased on me. A lot of people like to write that degree next to it to determine if it's higher on the top or bottom. Okay, so now it says draw them. I'm going to show you how to draw them on the graph. Now obviously you can put them in your calculator, but it'd be nice that you'd be able to do this on your own. So if I have a horizontal, this is where you need 2 different color highlighters. I'm going to highlight my vertical asymptote. Vertical, is that up and down or is that left to right?
Up to down.
Up to down. So at x equals 0, which is right here, I want you to go ahead and highlight that. Okay, that means that when you draw your function, you can't touch this line. It's a wall. That's why I highlighted it. If there's a highlighter there, you cannot touch it. It's a wall. It doesn't exist there. Okay? Now let's talk about a horizontal, different color. That's this way. It's at 0 again, but now I'm going this direction. So these are kind of cool the way that they look. It's a lot different than what you're used to. Okay. Now, This is when you would want to go in your graphing calculator and see what the graph looks like so that you can sketch it. I'm not asking you to be accurate. I just want you to sketch it. So go to y equals, please, in your graphing calculator. Go to y equals. And I want you to type in 4 divided by x. And press graph. Actually, you don't even need parentheses because there's nothing really going
Oh,
on.
they're not touching.
They're not, isn't that cool? So I'm actually going to graph it with you so you can see it.
Can I put zoom 6?
You can press zoom 6. It might help you in some of these. But what's cool is that you just identified that from your brain before you even looked at your graph. You were able to tell me what it looked like before you even put it in your graphing calculator. So hold on, I wanted to show you. It's really cool what these mathematicians have come up with for you to see things without using, because they didn't have technology back in the day that they could just do this. So they did this without calculators. So I'm going to go ahead and put that in. 4 divided by x. Because I want you, again, to understand what's going on and not just to memorize. So when I press graph, look at what happens. Okay, mine looks a little bit different than yours. Let me press zoom 6. Zoom 6. There we go. That's better. Now look. Do you see at that highlighter that I use here how the graph is not touching it?
Yeah.
And then here, it looks like it's approaching pretty closely, but it actually never touches it. And so we're just going to sketch it. I'm not asking you to be accurate, so I just want you to go like this. Sketch it out. Boom and boom. The only thing I'm concerned about is that if you touch that highlighting portion, you just cannot cross this line. You cannot cross that line. That's what you learned the past 2 days. Right there, in a summary. Yes.
Just because I'm curious,
Mhm.
would those lines be considered mirrors or something if there were 2 of them? What would happen if there was only 1 of them? Would they,
If there's only one, we'll get there. We'll get to that point.
okay?
Yeah. You can have just one. Yeah. You'll
Okay.
see what happens.
Okay, I'm just curious what that would look like.
It would look like if there's just one, like this, boom.
So there would only be 1 line.
There would only be one line. Yeah, and we'll get to those ones. Okay, now you've done this before. You might not remember it, but you actually did pretty well with this. Here we go. Remember, we labeled our graph. That's what Math 3 is. You bring everything ties together. I like to label my graph because this helps me when I do these types of problems. We're only going to do one more after this, so don't worry. It says, identify the end behavior. That just means arrows. Where is the arrow going when I talk about it in this situation? So looking at the horizontal asymptote, here's what I want you to do. Highlight or circle or star this piece right here. And I'm going to star it like a million times. If you know the horizontal asymptote, that's going to be your answer here. Everything ties together, but I'm going to explain it to you. Okay, what was our horizontal asymptote in this situation? So my answer then would be 0 and 0. And I'm going to explain it to you because here's why. Let's read it. As x is going to negative, here I am, I'm x. And I'm going towards negative, here I go. Do you see how the function is slowly going towards it? That's why it's going towards 0. Let's do the other side. As x is going to positive, so here I am, I'm x, and I'm going positive, positive, positive. Where is the function approaching? Do you see how it's slowly going towards 0?
Yeah.
That's why the answer is 0.
So they would actually touch.
They won't touch. It's just saying like where is it approaching?
Oh.
That's what that means. Good question. So that means as x is going to negative infinity, where is it going or where is it approaching? It's going towards 0, but it's not touching it. Now this is the one that we're used to, or we're not used to. This one's new. So that one we just did is something that we did before. This one's a little bit different. This one is going to be talking about the vertical asymptote. It was 0, so I want you to fill in your zeros in these 2 spots. I'll put a different color so you know that that's where I put it there. Okay? You okay? This is the only weird little strange one But again, it's pretty cool how you can do this level of math. It's pretty awesome. Here we go. As x is going towards your vertical asymptote, it's actually called asymptotic behavior, but I didn't want to put too big of words on there. A vertical asymptote. What we're going to do is we're going to do a negative here and a positive, and I'll explain what that is. That means when I'm coming in from the left, this one means when I'm coming in from the right. Make sure you're writing, please. This is all new, so I totally get why you're like, what's happening? I don't expect you to get it right away, but we will keep practicing, I promise. So this little negative means left. This little positive means right. And think about that in terms of math. Doesn't that make sense? Isn't the left side usually negative? Isn't the right side usually positive? Okay, so let me explain this, and I think you're going to get it after a couple of times of practicing. It says, as I approach 0, so here's 0. As I approach 0, and let me actually highlight that so that you know. Whatever color you highlighted, this part right here in green for me, highlight this, because that's what we're approaching. We're approaching that 0. As I approach 0 from the left, so here's 0 from the left, where is the function going down towards? Negative infinity. Let me do it again, and maybe you'll get it after this one. So here we go. This means as I approach 0 from the right. So here's 0, and I go right of it. Where is the function going?
Positive.
Positive infinity.
Wait, so can you explain that a little bit more?
Which one? This one?
Both of them.
Both of these?
Yeah.
Okay.
How do you start from 0? Where's 0
Which one? This one or this
at?
one?
The bottom one.
The bottom one.
Yeah.
Okay, so this is going to help you. It says identify the behavior of the vertical asymptote. So right away I want you to think, oh, it just told me something about the vertical asymptote, so let me go look up what it is. So I already found it. So you need to describe the behavior. Where is the function going, up or down? It's always going to be up or down. It's never going to be like a number. And so I'm looking at this asymptote from the left, and I'm looking from the right. Right? We're not going to do. Well, here's a question. Do I have any x-intercepts?
No.
No. Can anyone explain why I have none?
It's not touching.
Thank you. My heart is so big right now. Okay, what about the y? Yeah, none, because it's not touching the graph. Because right here, it'll never touch it. We're not going to make this. I don't care about that. However, I do care about the domain. Again, we're getting really smart in math here. This is pretty awesome. Can I ask you, will the domain be affected by the horizontal in pink or the vertical in green?
Horizontal.
Maybe both.
We'll find out. Okay, so I want you to think. Domain, is that left, right, or top, bottom, top?
Left.
Left, right? So here's my pen. If I'm going left to right, which one do you think is going to affect it?
The green.
The green one, the vertical asymptote. So I'm going to put a little star here. You will always use your vertical asymptote. And what's really cool about these problems is that they all tie together. You're going to be using the same numbers over and over again. So you're always going to be using that vertical asymptote. Always. You better have that number in your domain. So watch. So from this point, I would just like you to watch. I don't even want you to write anything. So where am I starting? I always start at the left. Where is this? Negative infinity. Where do I stop?
0.
0. Very good. So I'm going from negative infinity to 0. Wherever I stop is now where I start. So where am I going to start again?
So infinity.
Good. To
Infinity.
infinity. Very good. And I'll explain that once you write it down one more time.
And that's all the way, right?
That's it for the domain.
That's just because like there's like one from the right and one from the bottom left.
Yep.
But theoretically, wouldn't it be impossible for one of those other? But wouldn't it be impossible for 0 to ever start anything?
Well, here's a good question. So remember last chapter, you're like, why do I have these brackets? What do these brackets mean? Why do we have brackets? A lot of people ask that question. If you remember our domain from last chapter, don't write this down, was like negative infinity to 0 with brackets. Brackets include 0. Parentheses don't. So that's why we use parentheses, because we're not including 0, but we're saying every number up till 0 is what we're saying. This means I'm including it. We don't want that because we have a discontinuity there. Okay? Make sense?
Yep.
Still feels like a bit of a paradox to me, but I think I kind of get it.
Okay, we'll keep practicing. I want to do one more. Now that we have been introduced to it, it might actually go a lot faster. Okay, we're not going to do all of them. Let me actually pick out which one I want to do first.
Easy one. You know what, my name's just vision with you.
Let's do number 2. Okay. Now, you always want to factor something if you can. Can I factor anything out of the top?
Yeah.
What number?
0.
Factor.
1, 4.
4, I heard it. So I'm going to be left with x minus 1. And I'm just going to write everything else down so I don't forget. So that's always your first step. If you can factor, please do. Yes.
Okay, so you got the 1 because there's only one x, right? Or how did you get the 1?
This one?
Yeah.
So that you have to divide each one by 4. Because 4 divided by 4 is 1. And if you look, watch. 4 times x is 4x. 4 times negative 1 is negative 4.
Oh, so you can do that?
Alright.
Mm-hmm.
I was just confused.
It's okay.
Well, can we write down the whole?
Yeah, you're already seeing it. See, this is why I love it. You guys are actually getting it. It's going to be a whole because something cancels, but let's take it step by step. What are the discontinuities? I'm going to highlight 2 different things.
Negative 1.
Negative 3.
Negative 3
1.
and positive 1. You have to be careful. So I have 2 there. One of them is a whole, and one of them is a vertical asymptote. I already heard that someone already knew that there was a hole somewhere. Which one? This one, negative 3? Or 1 is the hole?
1 is the whole.
1 is the hole because I cancel.
Oh.
So now I'm going to say that I have a discontinuity at x equals 1 in my hole because I said holes right there. What is negative 3? Yeah.
Why do we put a line through the equal sign?
It means it does not equal. So it's saying like it cannot be negative 3.
And you divide 4 over x plus 3, or how do you do that now?
What are we talking about? Which one?
Okay. No, never mind. No.
Let's do B. Is there something that we didn't talk about? Which one's the vertical asymptote?
4.
Good, the negative 3. So I'm going to explain that one more time. I have 2 discontinuities. I listed them. Then remember, I told you that you just need to identify where they belong. Negative 3 is a vertical asymptote because look, it doesn't cancel with anything. And then 1 is a hole because it does. Okay? Yes.
Now that I think about it, why did you change the signs for 3 and 1?
Because you have to ask yourself what makes the denominator equal to 0.
Oh, now I remember.
It's okay. If you needed that little step, you can. Now, horizontal asymptote. Let's talk about it. What's my degree of the top?
4.
Degree.
Oh,
1. What's the degree of the bottom?
2.
2. Which one's higher?
The bottom.
So what's my asymptote from your chart? You got it. See, you're already starting to memorize it.
So when there's a huge number on the bottom, it's always y equals 0, right?
If the number's bigger on the bottom, it's 0, yeah. If it's bigger on top, it's none. Okay, all I want to do then is draw. Oop, my computer's dying. Let's draw the asymptotes. So here we go. I have a couple here. I'm going to do this color here. I have a vertical asymptote at negative 3, so 1, 2, 3. There we go. I have a hole at 1. Do you remember on the first day how I told you how to find the other part of the hole? This is from like the very first day. This is canceled. So I'm going to plug it into what's left over. And again, you can find this out on your calculator, but I'm showing you how to do it mathematically. Plugging in the 1. 1 plus 3. Let me know what you get when you plug that in your calculator. In order for you to find the other piece of your whole, you must plug it into what's left over. What'd you get? Good, 1. So my ordered pair is 1, 1. And that's the cool part, is now you can draw a hole there. So here we go. 1, 1, hole. Okay, you were sick that year. You were out of business. I'm not including it into my,
That's 2, 1.
because I can't count. 1, 1. Thank you. Now we have to do one more. Let's draw in our asymptote here at 0. Do you want me to, I'm just going to show you something. You can obviously just type this in your calculator and get the graph. But now from what I taught you, let's see if you remember. The end behavior is always going to be your horizontal asymptote. So what are these two numbers here? 0. Now here's the cool part. Technically you don't need a calculator because your brain is capable of figuring out how to draw this without it. Here's why. As x is going to negative infinity, where is the function approaching?
0.
0. Okay, so as I'm going towards negative infinity, I'm going to approach 0. What about as I go to positive infinity? Where's it going to approach? 0 as well. Very good. Okay, so you can actually draw this graph out without... Did I draw my asymptote wrong? No, I got it right. Okay, I'm just making sure. Okay. Let's go to our graphing calculator and see what it looks like. 4 over x plus 3. I would just type in your original problem. Don't do the factored one. It might be harder when you factor it. So let's type it in. So I'm going to go to y equals, and I'm going to clear it out. I have 4, use parentheses please. Oops, I didn't even do it myself. Parentheses, 4x minus 4. Okay, then I have divided by, this is where it gets a little tricky. You have to have 2 of these guys in your graphing calculator if you can't.
Oh. I didn't do this.
X plus 3 parentheses. For the sake of time, you can just watch me do it, and I'll teach you how to do this more in the calculator another day because I don't want to overwhelm you. But look at mine. That's what it looks like. Do you see how what our calculation said is correct at 2 or 3? Negative 3? So let's go ahead and draw that in. Just the way you're just sketching. I'm not asking for anything perfect. It's going to look something like this. Go by your hole. And something, what was it look like? Like that. Can always, Desmos is a lot easier to work with at home, so don't worry about that. I probably only will have you graph one of them on the homework. We still got 10 more minutes, so. Now, as x is approaching your vertical asymptote, which we highlighted purple, so I'm going to highlight that just so the same color so that you can coordinate it. So I have to put in my vertical asymptote was at negative 3 from the left and negative 3 from the right. I will give you these on the test. I wouldn't ask you to write those out. Now, here I am. This is where you'd want to watch. From the left, where is the function going?
Negative 30.
Good. From the right, where is the function going? Positive. Very good. So this one would be negative and positive. The rest, I'm just going to cross out. Don't worry about the domain for this one. I'll teach you how to do it a different day with a whole because it's a little bit different. Okay, so that was actually everything that you've learned the past 2 days, but I just put it in one problem. And that's what I was saying is I was trying to break it up for you piece by piece. Okay, I'm going to have you guys cross out a couple things on your homework.
Thank you.
You guys did very well. That was awesome. Good job. I know it's hard. You just need to keep pushing forward.
It's hard not to be on the phone.
Well, I'm proud of you for not being on the phone. Okay, on your homework. See? That's not it.
Wait for the, question one on the homework could be done for the
Yeah, just something.
discontinuities, right?
Oh, I'm
I
making
just
sure.
sent it.
What'd you say?
I was like, I don't
Okay.
know, like, so I'm 11:30 work adult sharp, and I think it had been too.
What'd she say? Nothing.
She's
Probably
probably
won't be fine.
not sure.
Okay, let's talk about the homework really quick.
Yes, homework.
We only have one more day of this chapter. That's it. That's why I told you it's a lot of weird and new stuff, but there's not that much of it. So we're going to keep practicing it. We only have one more day, and it's just extra practice. That's all. So like on Monday, I give you the graph.
Oh.
And that's it. So that's the only difference, is that I just give you the graph, which is actually easier than today.
2 problems, that's it?
Okay, so let's talk about this one. I want you to cancel out. F, G, and that's it. I also wanted to fill in one thing for you because I do it on the test, so I wanted to just help you out. Let's fill in this part right here where it says vertical asymptote end behavior. Put a 3 minus sign. Remember that means 3 from the left. This means 3 from the right. So I wanted to help you out because I will be putting those on the exam for you to help you. Because this is kind of hard. The rest you can do for sure. This one, I want to start it with you. It says factor first. What would I have to do at the top? What can I take out of both of them? 2, very good, and an x. Good, you guys did really good with that. Then remember you ask yourself, 2x squared divided by 2x is 1 what? 1x. And then when you do 2x divided by 2x, you just get 1. Now look at what happened. Look what you just created. What did you just create when you factored? A whole. I'm sorry, but like that made me so happy because like that's great. That's great. Okay, the rest you can do, but I want to cross out something.
F and G again?
I want to cross out
C. B.
F and G again.
I knew it.
And H, because I didn't teach you the domain with a hole yet. I'll do that a different day. Yes.
Wait, do we have to figure out the domain for the first one then?
17, 39.
Yeah, and that table. I don't know why you guys have a table. H. Get that away. Go away.
Both
I
Could be
H's?
like,
I think I might have deleted it already for next year because I knew I didn't like it.
Both H's?
There's like a.
so for the first question, might be no discontinuities.
There is.
There is a continuity.
So you see that table? Just cross that out. I don't want you to do that either.
What about I, number 1?
I want you to do I on 1.
Wrong.
I don't want you to do it on the back.
There
Hey,
could be no
when
discontinuity.
I was little, we had a pond in our house. Like a little pond in front of the walkway. And there was,
Good job today.
so I took my fishing pole, and it was an old goldfish.